Good morning, everyone. B flat. Today is the 8th of February, 2026. I was doing a review on Bobby Shafto's recording of the North Star going down the Puget Sound. At the 6-second mark, we have several things to reference. This buoy is TB, I believe it's called. It's the same size construction as TA, TB, and TC are all the same from what we can tell. Bobby did a video last year in May. How tall is the buoy? Well, it's about 13 feet based on his reference against a tugboat. I don't think that's going to come into play too much, but as we continue analysis, it may. Of course, we have the North Star coming in. Some notable features about the North Star would be its blue hole, the lettering tote that's on the side over here, a significant bow wave, and in the background, based on the location identifying TB buoy, the navigation channel buoy, the center marker, and Bobby has confirmed the location of where he was viewing from. We're able to identify that the area in the background is Dolphin Point. This is Dolphin Point. This is a line that stretches from Bobby's filming location right here, and somewhere down in here. It's easier to see on the other map. I made some other points on Google Earth, but just wanted to mention that this is 12.08 miles from the viewing point to Dolphin Point. Let's go into 2D for a moment. So in 2D, this is TC, TB, TA, and then further up there is T1, I believe it's called. I have this labeled wrong at the moment. I'll have to correct that. Again, we can go back to Bobby's location right here at the corner. These are the coordinates that he listed himself. The coordinates of TB, the buoy that we saw in the picture, and the one I originally thought from was TA, but it is out of reference. We don't see that in Bobby's video. So on the distant shore, let's try to get in here where we can start looking. Again, this line was in reference. It crossed right over from Bobby's location. It crossed over TB, and in the distance we're looking at this shoreline. One thing we can notice is it's a single level of houses to a tall tree line, and there's no other houses till you get farther up on the hill, and they are not viewed. We have the typical driftwood washing on the beach across this whole front section, and if we're referencing the ground in front of the houses, we kind of get a consistent 23-foot height. There was a 3-foot tide at the time of this, so it's more like a 20-foot reference to the grass, and the beach in front of the washing would be more like at 17 feet, based on the dimensions I'm getting here from Google Earth. So there are different points of the video, and anybody can play this out. It's on Bobby's site. But he'll go through, and eventually he'll have different places where I've taken a screenshot from. That wouldn't be one of them. Well, let's just go right to AutoCAD. So these are the screenshots, and there should be timestamps at 151. This one's again 151. I'll explain that in a second. And then one at 127. Now these two shots are the same screenshot, and what I was able to do is draw a reference line across this van body trailer, and knowing this dimension fairly closely, this is we'll dimension it out, but it's roughly 9'1" right now. It should be close enough for what we're trying to accomplish here. And that is about the height of the side of a van body trailer. If I have to go back and adjust this again, if it becomes argumentative, I will do that. And then I took and I drew in a reference line here over the T, just to kind of get an idea how tall the T was for the lettering on the side of the ship, and then a line from the bottom of the T to the water. These will become important when we get to the viewports or the paper space layouts that I've done, which we can dimension these things and analyze them a little cleaner. What I did in this second screenshot is I try to scale everything for the distance of the ship. I made this dimension the same as what I scaled in the previous shot that I was talking about, so that I could draw reference lines in different areas to measure. I can't measure directly from the PDF, but I can draw lines of what I want to measure, and once the lines are in place, since they're to scale to the PDF, I can dimension those in AutoCAD. So again, we can take a look at this vessel scaled at 3 miles, and I will pull up a couple dimensions here. 9'1½". The T on the toad is about 19'4", and it's about 11 foot above the water line. So this was the basing of the scale for the next view. If we go back to what's scaled for 9 miles, which is going to be over here, we can again take a dimension of the lettering. I got 19 foot 8 inches. Again, I was working pretty quick. I wanted to get close. Again, I can fine-tune everything if people need to continue to argue the point. (8'9" out of the water. Again, I could probably argue that down a little bit to be closer to that 10 foot. We have a bow height of 50 feet. I think Bobby's got that in his video. So we're fairly close. And lastly, the bow wave, about 8 feet. And you catch the spray. I could stretch a line out a little bit, but we're in the 8 to 9 foot range, I would say. I think I'm a little light here based on the shadowing above. But let's just leave that edit for now. We get to the point where we're going to be splitting hairs here, where there's other things that are significantly wrong. So this last shot, knowing that the bow, or that the side of the ship is 50 foot tall. Again, we'll take a linear dimension here. Got 50 foot 10 inches. We're close. It's probably a little larger than scale. And we've got 9 foot of a bow wave. The splash that's coming up the side that we can see. So now let's kind of think about what this all means. When this vessel is out at 9 miles, we should have a geometric horizon based on globe expectations, and we're going to put them out there because Bobby's crosshairs seem to indicate that he believes the geometric expectations are that of which is expected on the globe of 3959 miles. Now we should have a horizon at 5 miles, and then we should have about 10 foot of obstruction beyond the horizon. The height of the sagitta should obstruct 10 feet. Okay, I'm bringing this in here, this is where I got it from, and we're not going to talk about refraction and apparent Earth radiuses and all of this other nonsense. We're just going to talk geometric expectations, because Bobby's pushing geometric expectations with this line of level. So, if we're supposed to have just under 11 feet of obstruction, we should not see this 8 to 9 foot bow wave of this vessel. We should not see that at all. Yet, I'm measuring close to 8 feet of it. Based on the process of how I've measured here, we're seeing that. We can also take a look at these buildings on the shore and the shoreline down below, and the faint white edge across the whole shoreline that indicates we are seeing the driftwood, which is at the, I believe I said earlier, 16 to 20 foot height above water level. We have a 3 foot tide. So this is 16 to 20 feet above sea level. But what does that mean if that is at the 21 or 12.1 miles? And I'm working on that. Okay. Alright. We should have 34 feet obstructed above water level, above the tide. Okay? And we're seeing it. We're seeing down to, I'd say, 16 feet. Yeah, and this is 12 miles off of whatever quality camera was used in order to, to film this. And this has got very poor lighting. I mean, we have basically at 3 miles, this has to be an evening shot, and everything at Dolphin Point is sitting in shadows. You know, if we had better lighting, probably more of the houses would light up. Well, let's get back to that. Now, we are looking at an area that is in the shadows at this point. You know, the sun is back off to here, lighting the face of the vessel for the 3 mile observation. So Bobby's video was titled, let's go back to it. Angular drop is a sign of curvature. Unless Bobby's line of reference or plane of reference is a sloped plane that's being shot at an incline. You know, if it wasn't, we should see the sagitta. We should see all of the signs of the supposed curvature that goes along with the concept of drop of this vessel. Okay, angular drop of this vessel. I just don't really agree that Bobby has, you know, accurately depicted level, because the rest of the geometry does not jive. So, you know, I maintain that the piece of equipment being used and the way it's being used would naturally take a precision balanced instrument that, yes, again, is being used well beyond its recommended use, with a half-pound camera phone affixed to the back side of it. To me, it's naturally going to want to shoot high. Okay, that would just be the common sense of this. But that's how I've come to the conclusions that I've come up with. You know, it's not just saying I disagree with you for no reason whatsoever. I think I've pretty well laid out my case here. You know, I wish the image quality was better. You know, there was on some of these the where is it here? You know, when you zoom in on a poorly lit lettering on the side of the vessel, that's about the best you can come up with. Okay, but everything here, the bow, we're at 50 foot 1 inches. The bow wave, 8 feet. Lettering it at 19.8. What did I have here? I had it at 19.4. You know, 10 foot to the water line. We do have something going on here. You know, I've got the splash. There is, you know, reflection. We've got part of the mirage. I can't really identify exactly where the fold line is, but we do have the signs of, you know, the bottom of the T is here somewhere, very faint, and of course a bow wave at 9 foot 1. Again, this is probably scaled a little heavy, so that would cut down to more of the 8 foot. 8 foot 7, 8 foot 8, right where I was at with the other. I'm not far off here. This course analysis is sound. So we'll see what people seem to think at this point. Anyways, thanks for taking the time to entertain my analysis. Have a great day.